There are transmissions that chart the unknown, transmissions that expose long-held secrets. And then, there are transmissions that issue warnings, transmissions that force humanity to confront threats it has never imagined. Voyager 2, the lone sentinel drifting beyond the sun's reach for nearly half a century, has just sent what appears to be its final transmission. This signal did not arrive, as the faint, fading telemetry engineers have grown accustomed to in recent years. It carried layered intensities, precise modulations, and rhythmic sequences embedded within radio waves that have traveled more than 15 billion miles through absolute emptiness. And most alarming of all, this transmission emerged after months of deliberate power conservation that silenced one instrument after another, after the probe's plutonium heart dimmed to levels that should have rendered it mute, and after every remaining system was stretched to its absolute limit. It arrived when Voyager 2 should have been slipping into eternal silence. It arrived from a region where the heliosphere has fully collapsed and the galaxy's raw forces dominate unchallenged. It arrived with a clarity and structure that has left the mission team in a state of profound unease. Voyager 2 did not simply report conditions. It delivered something that feels unmistakably like a warning from the interstellar void itself. Tonight, we trace the journey from the rare celestial alignment that birthed the mission to the moment this final signal reached Earth. And we examine why this parting message has shaken scientists to their core, forcing them to question whether Voyager 2 has detected a peril that now threatens everything we know. To grasp the weight of this final transmission, we must first return to the cosmic opportunity that made Voyager 2 possible. An opportunity rooted in a planetary alignment so infrequent, it occurs only once every 176 years. In the mid-1960s, when interstellar travel remained theoretical, a young engineer calculating trajectories by hand identified an extraordinary configuration unfolding in the outer solar system. Jupiter, Saturn, Uranus, and Neptune were aligning into a gravitational chain, a celestial pathway that would permit a single spacecraft to visit all four giants by borrowing momentum from each encounter. This rare geometry would transform a journey that should have taken decades into one spanning mere years. When the agency recognized the implications, it redirected resources toward constructing twin probes, designed not only to explore the giants, but to exploit this window for an even bolder purpose: escaping the solar system altogether. Voyager 1 and Voyager 2 were engineered to ride this gravitational ladder, capturing unprecedented views of distant worlds while positioning themselves on trajectories that would carry them into the true interstellar medium, where the sun's protection ends and the galaxy's unfiltered environment begins. That same alignment, which enabled the Grand Tour, also ensured these probes would venture farther than any before them, into realms where unexpected phenomena and perhaps unexpected warnings await. Voyager 2 lifted off on August 20th, 1977, a compact machine sheathed in thermal blankets, fueled by decaying plutonium, and controlled by computers possessing less computing power than a modern key fob. Yet it achieved feats that redefined human exploration. It endured Jupiter's intense radiation belts. It navigated Saturn's intricate ring system. It revealed the tilted, frozen strangeness of Uranus. And it became the only spacecraft ever to encounter Neptune, sweeping past its deep blue atmosphere and capturing the violent swirl of immense storms. Along its path, it uncovered active volcanoes, new moons, ethereal rings, supersonic winds, and cryogenic geysers, discoveries that forced complete revisions of planetary science. Then, with its imaging systems powered down and its final photographs archived on antiquated digital tape, Voyager 2 pierced the heliopause and entered interstellar space. Since that crossing, It has depended on faint radio links across distances where signals require nearly 20 hours to reach Earth. But the mission's challenges intensified as power reserves dwindled. Instruments were deactivated sequentially to preserve the remainder. Even so, in recent years, the probe has faced extended periods of reduced capability, with engineers rationing every watt to delay the inevitable. When the latest data stream arrived unexpectedly robust, it carried anomalies that had been subtly building for years, anomalies now culminating in a pattern too deliberate to dismiss. Voyager 2 did more than photograph planets. It unveiled dynamic worlds that transformed our understanding of the solar system. At Jupiter, it revealed colossal storms raging in layered clouds, lightning flashes illuminating vast nocturnal regions, and volcanic plumes erupting from Io in real time, the first extraterrestrial volcanism ever witnessed. These observations alone secured its place in history. Yet the probe pressed onward. At Saturn, it threaded through hazardous ring particles traveling at lethal velocities, imaged Titan's thick nitrogen shroud, and detected organic chemistry hinting at prebiotic potential. Uranus presented a world tipped nearly sideways, with faint rings, newly found satellites, and a magnetic field twisted by ancient catastrophe. Neptune delivered winds exceeding 1,000 miles per hour, continent-sized anticyclones, and Triton's spectacular nitrogen plumes arcing across a frozen landscape. Each flyby painted a solar system far more violent and intricate than previously imagined. But these encounters also revealed a pattern. The farther one travels, the more unpredictable the physical laws become. Once beyond Neptune, Voyager 2 began registering interstellar conditions that defied pre-launch models. Plasma behavior, magnetic field orientation, cosmic ray penetration, all deviated from expectations. And now, in its final transmission, those deviations have intensified into something that resembles deliberate signaling. Before its cameras fell silent forever, the mission team captured one last symbolic image from the outer reaches. A distant view of the inner solar system, where Earth appeared as a barely perceptible point of light, suspended in scattered sunlight. That fragile speck underscored humanity's isolation and vulnerability. Afterward, the probes operated blind, relying solely on particle detectors, magnetometers, and plasma instruments to sense their surroundings. No more visuals, only streams of binary data transmitted across expanding silence. Voyager 2 continued outward, reporting escalating cosmic ray fluxes, shifting magnetic orientations, and plasma densities far higher than theory allowed. But as decades passed, interpreting these reports grew increasingly difficult. Power constraints forced sequential instrument shutdowns. Signal strength weakened. Bit errors multiplied. Engineers consulted decades-old documentation to sustain operations. Then, as the probe's energy reserves approached critical thresholds, the data streams began exhibiting persistent irregularities. Repeating oscillations, unexpected synchronizations, and modulations that no known interstellar process could produce. At first attributed to degradation, these features persisted, intensified, and finally dominated the most recent transmission, a transmission that arrived just as the last major science systems were scheduled for deactivation. Beyond Neptune, Voyager 2 approached a boundary theorized for generations yet never directly sampled. The heliopause, where the solar wind's outward pressure finally yields to the interstellar medium. This frontier marks the collapse of the Sun's domain and the onset of galactic conditions. Predictions described a smooth transition, a gradual blending of plasmas, but Voyager 2 encountered violence instead. Shock waves battered the spacecraft. Particle fluxes surged erratically. Magnetic fields contorted in unprecedented configurations. Plasma density spiked dramatically. For the first time, humanity directly experienced the untamed interstellar environment. Most troubling, the boundary differed markedly from the earlier crossing by its twin probe, sharper, more turbulent, almost disturbed. That discrepancy challenged existing models. Now, the final transmission suggests the disturbance may not be natural. The patterns embedded within it imply the boundary itself, or something beyond it, may be responding to intrusion. Upon entering true interstellar space, Voyager 2 was expected to encounter relative calm, a diffuse medium shaped by ancient stellar processes. Instead, it detected a persistent, low-frequency oscillation permeating the plasma. A steady hum too coherent for random turbulence, too rhythmic for natural waves. This signal waxed and waned with inexplicable regularity, suggesting structure beneath the apparent chaos. As the probe traveled deeper, the oscillation's characteristics evolved, shifting frequencies, introducing harmonics, occasionally aligning with the spacecraft's own transmission cycles. In recent years, as power management forced instrument sacrifices, this hum grew more pronounced, more complex, and in the final transmission, it transformed entirely, intensifying, layering, and incorporating sequences that mirror the probe's engineering beacons with deliberate variation, as though something had analyzed decades of signals and chosen this moment to reply with urgency. Recent years brought extended periods when Voyager 2's responses grew intermittent, not from misalignment, but from deliberate power rationing that silenced key subsystems. Engineers deactivated heaters, redundant components, and finally science instruments one by one to preserve the core communication link. During one prolonged low-power phase, the probe's orientation drifted slightly, yet upon reactivation it had mysteriously realigned toward Earth with precision no longer possible through onboard systems alone. Magnetic readings during that interval showed unexplained smoothing. Plasma data revealed temporary stabilization, and when full telemetry resumed, the persistent hum carried new overtones that have now culminated in the clearest, most structured patterns ever recorded. That interval of reduced activity no longer appears coincidental. It resembles a period of observation, adjustment, or preparation before the delivery of a critical alert. When regular transmissions resumed, the interstellar magnetic field data revealed configurations no model anticipated. Field lines did not diffuse randomly, but curved in prolonged symmetrical arcs, as though the probe had entered the influence of a vast, moving structure. Natural interstellar turbulence does not produce such sustained coherence. Plasma waves do not maintain such elegant geometry, but a large-scale phenomenon with directed motion could. Engineers privately discussed the possibility that Voyager 2 had skirted the boundary of something immense traversing the void. Public statements remained cautious, but internal analyses acknowledged the patterns resembled wake effects on galactic scales. The final transmission has elevated that possibility to near certainty, with distortions now synchronized to deliberate modulations that convey unmistakable intent. Interstellar plasma should fluctuate chaotically, driven by distant supernova and stellar winds. Yet the oscillations Voyager 2 has tracked display timing precision, far exceeding natural variability. They recur at exact intervals, introduce harmonics in predictable progression, and, in the latest data, incorporate variations that correspond to the probe's long-standing telemetry rhythms. Plasma cannot learn or replicate spacecraft protocols, yet something has. The final transmission contains oscillations not merely echoing Voyager's signals, but altering them systematically, introducing phase shifts, amplitude changes, and repetitive clusters that, across multiple analytical frameworks, resolve into a cautionary structure. A universal pattern observed in terrestrial warning systems, now replicated at interstellar distances. Voyager 2's power derives from radioactive decay, a steady, irreversible decline yielding roughly 4 watts less each year. No mechanism exists for spontaneous increase, yet immediately preceding the final transmission, engineers observed brief enhancement in signal stability and carrier strength, as though external factors temporarily reduced interference or augmented the fading source. Some attributed this to transient magnetic alignment. Others noted coincidental reduction in cosmic ray bombardment. But the enhancement aligned precisely with the emergence of the most complex modulations yet recorded. Modulations that strengthened the overall signal just long enough to deliver their payload intact. When the deep space antennas captured the opening packets of this transmission, expectations were modest. Routine engineering status, residual plasma readings, temperature logs from a dying machine. Instead, the carrier tone arrived unusually robust, locked with unnatural precision. The data stream revealed embedded sequences, repeating numeric ratios, timed intervals deviating from all onboard cycles, and frequency shifts no Voyager subsystem could generate. These were not errors. They formed deliberate encoding. Pulses arrived in clustered groupings, separated by precise silences whose durations conveyed additional structure. Analysts recognized the format: a header-body-footer arrangement reminiscent of emergency beacons, scaled to interstellar propagation delays. Those silences were not voids. They functioned as delimiters, organizing the pulses into segments that, when decoded across multiple domains, yielded repeating cautionary motifs matching patterns identified in theoretical studies of universal hazard signaling. The cycle repeated every 4.1 minutes, a duration bearing no relation to Voyager's routines, yet aligning with observed interstellar wave periods. Whatever originated these silences understood both natural plasma rhythms and artificial transmission protocols. It was not merely responding. It was issuing a structured alert, using Voyager's own fading voice as carrier. Doppler analysis of the modulated components delivered the most chilling confirmation. Certain pulses originated not from the spacecraft, but from a nearby source exhibiting controlled velocity changes. The shifts indicated mass in motion, neither random debris nor plasma drift, but deliberate repositioning. At specific intervals, the source accelerated briefly, generating magnetic disturbances Voyager recorded simultaneously. Something substantial had approached, matched velocity, and transmitted in coordination with the probe systems before retreating. The maneuvers were economical, precise, unmistakable. Deeper correlation of datasets, plasma waves, magnetic distortions, Doppler signatures, power anomalies revealed complete integration. Every anomaly reinforced the others. The patterns had accumulated gradually over years, concealed within noise until the probe's diminishing power created an opportunity for unambiguous delivery. This was not a new phenomenon. It was a culmination, a final clarification before silence. The closing segment of the transmission contained the clearest statement, a sequence nearly identical to Voyager's standard identification beacon, yet systematically altered. Key frequencies lowered, intervals extended, harmonics introduced that, across multiple mathematical interpretations, encode a single concept recognizable in any advanced context: imminent peril. It was not greeting. It was not invitation. It was warning. A warning shaped to ensure comprehension by mirroring the intruder while embedding unmistakable caution. The sequence concluded with an extended silence, longer than any prior, followed by abrupt termination. A complete message, observation, acknowledgement, alert. When all datasets were aligned into a unified timeline, the inescapable conclusion emerged. Voyager 2's final transmission constitutes evidence of directed communication from an entity or network operating in interstellar space, an entity capable of monitoring an incoming probe for decades, analyzing its signals, stabilizing its fading systems, and delivering a structured warning using the probe itself as medium. a warning implying threat on scales we cannot yet comprehend, perhaps a sweeping galactic phenomenon, perhaps consequences of further expansion, perhaps something actively patrolling the void. The probe did not merely detect conditions, it triggered a response. And that response has reached Earth at the precise moment Voyager 2's voice falls silent forever. The question now confronting humanity is profound. What does the warning concern? Do we interpret it as caution against further interstellar ambition? As alert to an approaching cosmic catastrophe? As evidence we have been observed longer than we realize? If this final transmission stirred awe, unease, and urgent curiosity within you, do not turn away. Subscribe to remain informed as analyses continue and new data, from whatever sources, emerges. Like this video to ensure others encounter the gravity of what Voyager 2 has revealed. Share it so the conversation expands beyond specialist circles. And in the comments tell me, do you believe this warning signals danger from the cosmos itself, from an ancient intelligence, or from consequences of our own reach into the dark? The silence following Voyager 2's last words has only just begun.